Our next example, example 2, find the hydrostatic force on one end of a cylindrical drum with radius 3 feet if the drum is submerged in water 10 feet deep. So in this problem, we have a couple different ways of setting it up, but we are going to set it up so that we can have a convenient equation for the equation of our drum. So since we're talking about a circle cross section and we're just looking at the force on this cross section, we're going to use the equation of a circle, x squared plus y squared equals r squared, and then we're going to take the origin to be at the center. So because of that, now when we measure, we are going to be measuring it in terms of y, and so in this problem we're going to need y to start at positive 3 all the way down to a y of negative 3. Okay, so to find the force on the ith strip, we need the pressure on the ith strip and the area of that strip. Also notice that we're dealing with feet, so remember our density for water in terms of feet is 62.5 pounds per cubic foot. So we need area and we need pressure. So the area, we're dealing with a rectangle, so the area is going to be the square root of 9 minus our y squared. That's going to be this width here, but we actually need double that there times the thickness up and down, which would be our delta y. So that's the area. It's just a base times height. For the pressure, remember the pressure is the density times the depth. So we have 62.5 is our density, and then our depth, we could write d sub I. But we want the depth to be in terms of y. So 62.5 times 7 minus y. So if we think about it, when y is 0, we should have a depth of 7. When y is negative 3 at the bottom, we should have a depth of 10. When y is positive 3, we should have a depth of 4. And so that all works out. So that's y sub I. That's a sub I as well. Okay, so to get our force of the ith on the ith rectangle is going to be 2 times the square root of 9 minus y squared times 62.5 times 7 minus y delta y. Then, taking this limit of the sum, we can go straight to the integral from negative 3 to 3 of 2 root 9 minus y squared times 62.5 times 7 minus y dy. So this this integral is not too bad. We can split it up into two parts. We can factor out constants, and then we can also use some symmetry to integrate. So really, we're dealing with these two integrals. We've got our 2 times 62.5 times the integral from -3 to 3 of 7 times the square root of 9 minus y squared dy minus the integral from -3 to 3 of y times the square root of 9 minus y squared dy. And if you're watching closely, you'll notice this is an odd function integrated from -3 to +3, so it will give us a 0 right there. And then for the second part, we have a couple of options. We could use trig substitution. Notice there's no u substitution wouldn't work well because there's no y here. Or we could use the fact that we are looking at, this is the area of a semicircular disk with radius 3, and use geometry to solve this. So if you use geometry, you get a half of pi r squared, so that would be 1/2 pi times 3 squared. So we would end up with something like 2 times 62.5 times 7 times 1/2 pi r squared. And that works out to approximately 12,370. And we're talking about a force, we're talking about pounds.